seems more and more complex. All we can say of it is but approximate, and our formulae are constantly requiring new terms. But the ranks are unbroken. The relations that we have discovered between objects we thought simple still hold good between the same objects, when their complexity is recognized, and that alone is the important thing. Our equations become, it is true, more and more complicated, so as to embrace more closely the complexity of nature, but nothing is changed in the relations which enable these equations to be derived from each other. In a word, the form of these equations persists. Take for instance the laws of reflection. Fresnel established them by a simple and attractive theory which experiments seem to confirm. Subsequently, more accurate researches have shown that this verification was but approximate. Traces of elliptic polarization were detected everywhere. But it is owing to the first approximation that the cause of these anomalies was found in the existence of a transition layer, and all the essentials of Fresnel's theory have remained. We cannot help reflecting that all these relations would never have been noted if there had been doubt in the first place as to the complexity of the objects they connect. Long ago it was said, if Tycho had had instruments 10 times as precise, we would never have had a Kepler, or a Newton, or astronomy. It is a misfortune for a science to be born too late, when the means of observation have become too perfect. That is what is happening at this moment with respect to physical chemistry. The founders are hampered in their general grasp by 3rd and 4th decimal places. Happily, they are men of robust faith. As we get to know the principles of matter better, we see that continuity reigns. From the work of Andrews and van der Waals, we see how the transition from the liquid to the gaseous state is made, and that it is not abrupt. Similarly, there is no gap between liquid and solid states, and in the proceedings of a recent Congress we see memoirs on the rigidity of liquids side by side with papers on the flow of solids. With this tendency there is no doubt a loss of simplicity. Such and such an effect was represented by straight lines. It is now necessary to connect these lines by more or less complicated curves. On the other hand, unity is gained. Separate categories quieted, but did not satisfy the mind. Finally, a new domain, that of chemistry, has been invaded by the method of physics, and we see the birth of physical chemistry. It is still quite young, but already it has enabled us to connect such phenomena as electrolysis, osmosis, and the movement of ions. From this cursory exposition, what can we conclude? Taking all things into account, we have approached the realization of unity. This has not been done as quickly as was hoped 50 years ago, and the path predicted has not always been followed, but, on the whole, much ground has been gained. End of Chapter 10.